Welcome to our 11th video in our SOLIDWORKS What's New for 2025 series. My name is Ed Hawkins, and over the next few minutes I will take you through the updates to simulation in SOLIDWORKS 2025. The Proteus Motion is a training tool built to perform for professional athletes. This handle is how the athlete connects to the machine, and ensuring the athlete's safety while using the Proteus Motion is extremely important. The handle needs to be both strong enough to endure the forces of a Major League Baseball swing and lightweight enough to simulate the feel of the bat in the hitter's hands. It is a highly designed assembly that will need to be virtually tested to meet all of the design's criteria. Let's take a look at how we can use some new features in SOLIDWORKS 2025 to speed up the analysis of this handle and also increase the accuracy of the results. Firstly, there are several components that are required for the handle to function properly, yet many aren't integral to the handle's structure. New in 2025, we can now select the structural components we want to keep in the analysis and exclude all the others. This is a huge time saver when working with large assemblies. These moving parts are all connected with pins. Virtual hardware is a great way to reduce the overall scope of the analysis without sacrificing accuracy. Now virtual pins can be defined using distributed coupling technology, which more accurately transfers loads to the surfaces where the pins are located, increasing the overall accuracy of the analysis. This handle is connected to the rest of the Proteus Motion machine, but adding a rigid boundary condition would over-constrain the model. In reality, there is some compliance to the rest of the machine, which would act as a stiff orthotropic spring. New in Simulation 2025, a new orthotropic spring type can be defined with unique stiffness values in all orthogonal directions, plus torsional and bending stiffness as well. Before we run the study, we'll need to mesh the model, and in 2025, assemblies that contain identical parts will mesh up to 15% faster while using the blended curvature-based mesher. Let's switch over and take a look at plastics now. Some components of the Proteus Motion are plastic. We want to make sure they look aesthetically pleasing and also fit, form and function properly. Plastics 2025 can help in designing the perfect part right from the get-go. The new results breaks down overall warpage displacement into unbalanced cooling, orientation and non-uniform shrinkage, giving better insights into deformation characteristics. A new and more accurate solver is used to compute sink marks. This ensures the virtual prototype more closely matches the physical one. So to review, we've seen a new option to exclude others from the analysis, a new general spring connector, an enhanced pin connector, and the ability to reuse the mid-side node for meshing. 2025 also gives us an improved accuracy with node to surface and surface to surface bonding. In Plastics 2025, a new warpage result allows us to understand the causes better, and a new solver helps with sink marks across multiple components. Thanks very much for watching, and look out for our next video on what's new in DraftSight for 2025.